Good day, guys. Today's lesson we're talking about differentiation and integration, and it's not actually something that is tough. And actually, couple us right here, but most of us feel is tough actually. Differentiation and integration. Now, just know that integration deals with when you hear the word differentiation, you can hear difference, subtraction. This is what minus 1. Integration is what plus 1. That's the first you have to know. And this minus 1 plus 1 actually affects, it actually works in their powers, their index. Do you understand it? Now we have something like this and asked to find the n-time derivative of this. You say x to the power of what? N. We are asked to find the n-time derivative of this. How can we go about it? Now, differentiation entails that you take the power and times this, and then subtract that same power by minus 1. That's differentiation. I mean this. The power is what? N. You now have n times x, still n minus what? 1. This is it. This is what differentiation means. So that's why if you have something like this, d over dx of, let me say, x power of what? 4. This thing means that 4 times this. Now 4 times x is what? Now 4 the power times this. 4 times what? X. Let me see. 4 times x is what? 4x. The power will now be what? 4 minus 1. This is equal to what? 4x cubed. That is what this thing actually means. 4x cubed. And if you can integrate this, and when you integrate this, you come back to having this thing. You come back to having its differentiation. And integral of 4x cubed. And I told you the integration is to what? Plus 1. And now watch now. By integration, this will not come at times 4. That's what happens. 4x, 3 will not add 1, and that power, you use that power and divide everything. 3 plus 1. We should now look like this. 4x power of what? 4, divided by what? 4. And this will cancel this, leaving us with what? X to the power of 4. And this is it. So that means when you differentiate and get this, if you integrate what you got, you come back to this. So that's the basic point. And also differentiation is the power who times this first of all, and then minus 1. But integration means that power plus it by 1, take the whole power and then divide it. And let's solve the bit complex solution. So we have to find this n-time derivative of, let me use this for instance. Okay, let me say I give you like something like 7 dx. We are asked to find something like this. Remember, we are not giving anything inside here. Just be mindful of this. When you see something like 7dx, they will not put this bracket actually. They will combine it together, but separate it so for easy understanding. You take that x here and put it back here. If here is the y, then this one was 7y. Okay, at this point, let's add an index. Let me say 2. Yeah. 7x cubed dx. You get it now? So now to differentiate this, we now have, remember the power first of all times the whole number or the constant or the variable beginning. We now have this one equals 2 times 7x. We now have this equals 2 minus 1. Since we are talking about differentiation, this one equals 14x. 2 plus 1, 2 minus 1 is also what? 1. So it's something as you not adding the what? 1. The answer is what? 14x. Right? Yes. And when we differentiate this now, let's see. when you integrate this rather, sorry, integral of 14x is you write 14x, you have an invisible one here, right? Plus 1, all divided by what? 1 plus 1. And integration deals with a constant. We have a constant of the integration, which is what? C. But the constant is not actually, okay, so you can add it. That's a constant C. Let me add it for further emphasis. Now this value be like this. 14. The plus C should not be disturbing you. If you feel it disturbing, just clean the plus C. Once you get your answer, just come and add it plus the constant, please, to avoid confusion. Am I okay with that? So this is 14. Now x squared divided by what? 2. And 2 going here, we're going to have 7. This is going to be what? 7x squared. And if you look here, you now see that the integral of this 14x is this. I see the figure. When you differentiate this, you get this. When you integrate this, you get this. So that's just the logic behind this.